Okay, so now let's take a look at H2SO4 and H2SO3. Write the conjugate bases of each of those acids and identify the stronger acid. So we've got, I'm tilted a little bit, sorry. Okay, so we've got H2SO4 and we've got H2SO3. Both of those are acids, and we need to identify the conjugate base. So as we talked about before when we were doing these things, the acid, they give up a hydrogen and become a conjugate base. So here, if I give up one of these hydrogens, it becomes HSO4 negative. And if I give up one of these, it becomes HSO3 negative. As for which one is the stronger acid, let's take a look at the previous page at this figure. And let's look for the acid H2SO4. Okay, so that's going to be up here, and HSO4 is the conjugate base, just like we said, so good on us. And then H2SO3 is right here, and its conjugate base is HSO3, so good for us. Okay, so just looking at this, we had, what did we say, H2SO4 right here, and then we had H2SO3 right here. The arrow pointing up means you've got the stronger acid, so H2SO4 is our stronger acid. But the way the textbook also wants you to think about it is very strong acids make very weak conjugate bases. So they're great at being acids, they're not so great at being bases. Being acids are their thing. That's how I like to think of it. So the way the base part of it works is the arrow points down and the stronger bases are down here. So this conjugate base is weaker than this one, and that makes this acid stronger than this one. So H2SO4 is the stronger acid. All right, and I realize I forgot to mark the last one, but we said it in the video, so that's fine. Okay, so next for B, in each pair write the conjugate acid of each base and identify the stronger base. So we've got CO3 negative, or we've got PO4 3 negative. So to make it a conjugate acid, up here when we had bases, they became conjugate acids because they received a proton. So this will become HCO3, and instead of 2 negative, it'll just be 1 negative because a hydrogen got added on and paired up with one of the 2 negative charges here. Same idea with this one, HPO4 2 negative. So instead of there being 3 negative charges, the hydrogen came and took one of them. So now there's just the 2 negative charges. That was me trying to do fingers. Okay, so then we'll take a look over here and we'll look at the base side. Here is CO3 2 negative and PO4 3 negative. And here are their conjugate acids. And that's what we said here. And so this PO4 3 negative is closer to the bottom, and with this diagram, closer to the bottom is the stronger base. So strong base, stronger base, weaker acid, stronger acid. Now for the very last one, we've got HCO3 negative and HPO4 2 negative, and these are bases. We're going to turn them into conjugate acids by adding a hydrogen, so that's H2CO3, and then this one is H2PO4 negative. So -1 paired up with the hydrogen, neutral. One of the 2 negatives paired up with the hydrogen, left 1 negative. And then if we look over here, we've got as bases HPO4 2, and then we've got HCO3 right here. And then these are the acids that they make, and that's what we got. And stronger acids are up high, so stronger acid and weaker acid. Weaker conjugate base, stronger conjugate base.